Like this you can solve any problem. So that means you have to find out the a naught value, an value and bn value by using that Euler's formula. Okay, but you have to integrate carefully. So integration and applying the limits part is very important. Okay, so next problem, find the Fourier series for f of x equals to x square. So given that limits are minus pi to pi. Okay, so see here we have the Fourier series f of x equals to a naught divided by 2 plus summation n equals to 1 to infinity a n cos nx plus summation n equals to 1 to infinity b n sin x. Consider this as equation 1. Now consider the given function is f of x equals to x square. Okay, and the limits are, that is intervals are minus pi to pi. So here a naught value becomes, after practicing some problems you will get the idea. Okay, there you can reduce the steps. So integration minus pi to pi x square dx. So integrating this one we get x square integration is x cube by 3 minus pi to pi. Okay, or you can use that indefinite integral formula also, because it is a even function. You can write it as 1 by pi. So minus pi to pi can be written as 2 into 0 to pi x square dx. Okay, this is for the even function. So that is by using this definite integral formula. So minus a to a f of x dx is equals to, so this is equals to 2 into integration 0 to a f of x dx. This is for when f of x is even function, and 0 for when f of x is odd function, right? So since x square is a even function, okay, so therefore we add this formula, or you can directly calculate it. Okay, so that means, so we start with we start here only. So 1 by pi x square integration is x cube by 3 minus pi to pi. Now on adding limits here we get 1 by pi. So by using these two formula we get the same answer. Okay, x cube means first applying upper limit pi cube by 3 minus lower limit minus pi cube, so that is minus pi cube by 3, will get 1 by pi cube by 3 minus into pi, minus of pi cube is equals to, will get minus pi cube, minus into minus plus pi cube by 3, which is equals to 1 by pi cube by 3, pi cube by 3 is equals to 2 pi cube by 3. Okay, so this 1 pi term get cancels, we get 2 pi square divided by 3. So this is the a naught value. Okay, similarly we can calculate an and bn values. For an we consider the formula 1 by pi integration minus pi to pi f of x into cos nx dx, that is equals to 1 by pi integration minus pi to pi x square cos nx dx. You can observe that here x square is even function and cos nx is also even function. So even into even you will get even only. Therefore x square cos nx is equals to even function. So here we use the definite integral property, that is this formula directly. So using this formula we get, so this can be an can be written as an is equals to, so for this limit it can be replaced by 2 into, so that is 2 pi by into 0 to pi. Okay, so on using this formula, this x square cos nx dx as it is. So this is only for the limit. Okay, so if we change this one, it is easy to calculate. Now again we use the Bernoulli's equation. On using Bernoulli's equation we get this an 2 by pi as it is, x square as it is, integration of cos nx is, sorry, sin nx divided by n, it is plus only, minus x square differentiation 2x, sin nx integration is minus cos nx divided by n into n equals to, we get n square. Next again 2x differentiation is 2, okay, into minus as it is cos nx integration is sin nx divided by n cube, and the limits are 0 to pi. Okay, now 2 by pi, applying limits, okay, that is 0 to pi. So again you remember that we have to add limits only for cos terms, not for the sin terms, because for sin we get sin of n pi is equals to 0. Okay, therefore add the limits only for cos terms, not for the sin terms. So here we get directly 0 for this one. This is cos term, therefore on adding this limit, upper limit, we get 2 pi minus cos of n pi divided by n square. Next plus again we get 0. Now minus lower limit, sin of 0 equals to 0, this minus, already minus is there, minus into minus plus, we get 2 into 0 equals to 0, therefore it terms becomes totally 0. Okay, for lower limit all these three terms become 0, because sin of 0 equals to 0, here 2 into 0 equals to 0, and this sin of 0 equals to 0, so lower limit totally becomes 0, therefore here we get 2 pi minus into minus plus 2 pi cos n pi divided by n square. This pi get cancels, therefore it can be written as 2 into 2 is equals to 4. Okay, cos n pi value is equals to minus 1 power n divided by n square. Since cos n pi value is equals to minus 1 power n. Okay, so this is an value. So similarly for bn, 1 by pi minus pi to pi x square into sin nx dx. Okay, this is the formula. So you can observe that on using this definite integral formula, this one minus a to f of x dx equals to 0 when f of x is odd. You can observe that this x square is even, but sin function is always odd. Even into odd equals to odd only. So that implies x square sin nx dx is, sorry, this is equals to odd function. For odd function we get 0. Therefore bn value is equals to 0. Right? So that is by using definite integral property, we can directly write bn is equals to 0. Now substituting a naught, an and bn values in equation 1 in this Fourier series we get f of x equals to a naught value is 2 pi square by 3. So substituting 2 get cancels, we get pi square divided by 3 plus summation n equals to 1 to infinity. An value is this one, 4 n square into minus 1 power n cos nx. So here plus we get 0 because bn value is equals to 0, or you can write it as n equals to 1 to infinity. Bn value is 0 into sin nx. So simplifying this one we get f of x equals to pi square divided by 3 plus we can take this 4 outside, 4 summation n equals to 1 to infinity minus 1 power n divided by n square cos nx, which is the required Fourier series. Okay. Next problem, construct Fourier series for function f of x equals to minus k when minus pi is less than x, which is less than 0, and plus k when 0 is less than x, which is less than pi. So here given intervals are minus pi to pi only, but this interval is divided into two intervals, that is first minus pi to 0 and 0 to pi. Okay, if we calculate length of this period, this is 2 pi only, but this function is divided into two intervals, therefore the formula will be same, but in the integral we have to take two integrals. First integral for this minus pi to 0 f of x, and plus for next we should consider 0 to pi for the second one. So this is f of x consists two intervals, first interval and the second interval. When f of x is minus k, then we have these intervals. Okay. Solution. Given, first write the given, f of x is equals to minus k when this x lies between minus pi to 0, and plus k when x lies between 0 to pi. We know that the Fourier series is a naught divided by 2 plus summation n equals to 1 to infinity an cos nx plus summation n equals to 1 to infinity bn sin nx. Okay, consider this as equation 1. Now for a naught we consider 1 by pi. So here actually we have the formula integration of x dx. Since here given intervals divided into two intervals, therefore we should consider it as integral 0 to minus pi to 0 f of x dx plus 0 to pi f of x dx. Okay, so this is the limits, that is the given intervals are minus pi to pi only, or this is equals to 1 by pi integral minus pi to 0. So when minus pi to 0, the intervals are minus pi to 0, then f of x value is minus k. So it is minus k into dx plus 0 to pi k dx. Now integrating this one we get 1 by pi. So minus k integration is minus k into x, and for this limits are minus pi to 0 plus k into x, for this limits are 0 to pi. Now applying limits here we get 1 by pi. So minus k become constant. Applying upper limit minus of lower limit, minus into minus we get plus pi plus k into upper limit minus lower limit. So simplifying we get 1 by pi minus k pi plus k pi. So this get cancels, we get 0. Therefore a naught value is equals to 0. Next we calculate an value. An is equals to same 1 by pi integral. We should consider two intervals, that is minus pi to 0 f of x cos nx dx plus integral 0 to pi f of x cos nx dx. Okay, so 1 by pi so here minus pi 0, when limit intervals are minus pi to 0, then we have f of x value is minus k cos nx dx plus interval 0 to pi plus k cos nx dx. Now simplifying this one, that is integrating, we get minus k is a constant. So cos integration of cos nx is sin nx divided by n, and the limits are minus pi to 0 plus k is constant. Cos nx integration is sin nx divided by n, limits are 0 to pi. So applying limits, that is evaluating limits, we get pi minus k. So here n can be taken outside. So sin nx, sin of 0 equals to 0, sin of any pi equals to 0, therefore we get 0 plus k constant. Again sin of pi is equals to 0, sin of 0 equals to 0. So totally we get k into anything equals to 0, therefore it becomes 0. So an value is also equals to 0, right? Next we calculate bn value. Okay, bn equals to 1 by pi integration minus pi to 0 f of x sin nx dx plus integration 0 to pi f of x sin nx dx. Okay, now we add the f of x values here, that is 1 by pi. When limits are minus pi to 0, that is intervals are minus pi to 0, then f of x value is minus k. Okay, that is minus k into sin nx dx plus 0 to pi k sin nx dx. Okay, so which is equals to 1 by pi. Integrating, we get minus k becomes constant. Sin nx integration is minus cos nx divided by n, limits are minus pi to 0 plus k into minus cos nx divided by n, and the limits are 0 to pi. Okay, now applying limits, upper limits and lower limits, we get 1 by pi. Okay, minus k as it is, so minus into minus plus k by n we take outside. Now here cos of 0 minus lower limit cos of n minus pi plus again same, plus into minus, we get minus k by n can be taken outside. Now applying limits, here we get minus, we have already multiplied it, so cos of n pi minus cos 0. Okay, so got it. So here we apply limits, here upper limit minus lower limit, so minus into minus plus k divided by n can be taken outside because these are constant. Now applying limits, upper limit cos of 0 minus of lower limit cos of n minus pi as it is. Okay, next plus into minus, minus k by n can be taken outside, cos of n pi minus cos of 0. Now further simplifying this one, we get 1 by pi, this kn can be taken out, k by n can be taken outside. Okay, here we get cos of 0 equals to 1 minus cos of minus theta is equals to, we get cos theta only, therefore it is cos of n pi only. Next minus, again it is cos of n pi, minus into minus plus cos of 0 equals to 1. So we get k n pi in the bracket 1 into 1 2 minus into minus minus we get 2 cos n pi, or this can be written as 2 can be taken outside, that is common. On taking 2 common, we get 2k divided by n into pi. This can be written as 1 minus cos n pi, means it is minus 1 power n. So since cos n pi is equals to minus 1 power n, so this is the Pn value. Okay. Now substituting an, a naught and bn values into equation 1, that is in the Fourier series, we get equation 1 implies f of x equals to a naught value is equals to 0, even an value is equals to 0, we get only bn terms, that is summation n equals to 1 to infinity. Bn value, we substitute this bn value 2k n pi into 1 minus 1 power n into sin nx. So this is the required Fourier series. Okay. Note, suppose if you substitute n values here, it is n equals to 1, n equals to 2 and so on, we get this becomes f of x is equals to, so substituting n values we get 2k by pi is constant, 2k by pi, so 1 by 1, 1 by n means it is 1 by 1, 1 minus even power, for even power we get 0 here, so sine of any terms equals to sine of x, so here 1 by n means 1 minus, here for odd term we get minus 1, minus into minus plus 1, sine into 1 into x is equals to sin x. Next, for 2, for n equals to 2 we get 1 by 2, 1, so if power is even then we get plus 1, plus 1 into minus 1 equals to we get 0, so second term becomes 0, for even terms it becomes 0, plus again 1 by 3, next again it is 1 plus 1 is equals to, for n equals to 3, so this becomes odd term, minus 1 power odd is equals to, you get minus 1, minus 1 into minus 1 equals to plus 1 into sine 3x and so on. So further simplifying this one we get 2k by pi, 1 plus 1 is equals to 2 sin x, so this is 0, plus 1 by 3, so that is 2 by 3 sin 3x and so on. Or in each case we get 2 common, on taking 2 common it becomes 4k pi, here we get sin x plus 1 by 3 sin 3x and so on. Okay, so in the exam sometimes they may ask that show that like this. Okay.